This is one of Europe's biggest construction sites, perhaps even the biggest. Hinkley Point C is the first nuclear power plant the UK has built in decades, and it's set to usher in a whole new generation of energy infrastructure for the country. But it's been beset by huge delays, environmental disputes, and cost rises, to the point where it's now expected to become the most expensive project of its kind ever built. And with other schemes due to follow its blueprint, the pressure is now firmly on to finish the job. This is the story of Britain's divisive nuclear megaproject, a spectacular feat of engineering at risk of being overshadowed by controversy. In the mid-1950s, after the horrors of Hiroshima, 3 nations began a race to develop nuclear power for uses other than bombs. The Soviet Union was the first to generate electricity with atomic energy in 1954. 3 years later, the US unveiled a full-scale nuclear power plant dedicated to peaceful purposes before anyone else. But in between, the UK made its own piece of history. There's nothing like it anywhere in the world. Neither Russia nor the United States is yet creating electric power on this scale from the atom. At the Calder Hall Power Station in northern England, atomic energy was used commercially for the first time, although its main purpose was to make plutonium for nuclear weapons. Still, that meant the UK was once a pioneer in the field of nuclear, which continues to be a major source of energy well into the 21st century. So surely then, its mission to construct a brand new power plant has all gone swimmingly. Well, no, not really. It's taken much longer to build and become way more expensive than predicted. The project has gotten extremely complicated and pretty chaotic. However, delivering 2 new nuclear reactors after not building any for a very long time is challenging to say the least. You see, right now, there are 9 nuclear reactors operating in the UK, over 5 sites. Together, they generate around 13% of the country's electricity, but many of them are nearing the end of their lifespans based on old technologies, and either due to be decommissioned or have already started the process. 6 have been shut down in just the last few years, and there hasn't been a new power plant built here since the 1980s. And yet, that doesn't mean the UK has given up on nuclear completely. Quite the opposite, in fact. It now plans to build as many as 8 new reactors between now and 2050. That might sound a long way off, but Hinkley Point C is providing a quarter of those new reactors on its own, and the project is simply enormous. The spot where it's being built, on the south bank of the Bristol Channel in Somerset, England, is widely considered to be Europe's largest construction site. Spanning 430 acres, it dwarfs the plants beside it, Hinkley Point A and B, built in the 50s and 60s and now closed. When complete, Plant C will produce 7% of the UK's electricity, enough to power 6 million homes for 60 years. Okay, but how is this all coming together, and what even are the main components of a modern nuclear power plant? First, it's important to understand the basics of where all that power is coming from. Yes, we're talking about the reactors. To put it simply, it's the part of the system where uranium atoms are split through a process called fission. This creates heat, which converts water into steam. Next, the steam is used to turn a turbine, generating electricity. As if building the first British nuclear plant in over 30 years isn't a big enough challenge, it's the first time EPR reactors have been used in the UK. EPR stands for European Pressurized Water Reactor. They've already been deployed in other areas of the continent, at Flamanville in France and Olkiluoto in Finland. Both of those are new and were built by EDF, the energy company now fully owned by the French government, which just so happens to be in charge of Hinkley Point C. These reactors use 17% less uranium than older technologies and have 4 safety systems to protect against hazards like floods and earthquakes. Not that we get many of those in the UK, but better to be safe than sorry. Now, let's get back to that enormous power plant and try and decipher where you'll actually find the reactors at Hinkley Point C. Well, they're located in the reactor buildings, and you really can't miss them thanks to their huge size. Like almost every structure on this site, a great deal of machine power was necessary for their construction. In fact, because so much of the construction requires massive segments to be moved around simultaneously, there are cranes everywhere, more than 50 of them at a time, including one that stands out from the rest. Meet Big Carl, the world's largest land-based crane. Carl has been used for a number of heavy lifting tasks, including putting the dome onto the first reactor building and placing the giant liner rings, which weigh hundreds of tons each. There are 3 of them on each unit, and together they form part of the inner containment wall. Once in position, they are encased in 2 layers of concrete. Vast amounts of the material were needed overall, 25% more than on the power plant's Hinkley Point C was modeled on. 9,000 cubic meters of the stuff were poured in one go for the base of the first reactor, beating a record held by London's Shard. This is because British regulations required a number of changes compared to those sites in France and Finland. Not a small number either. 7,000 alterations were carried out to make it compliant. As well as all that extra concrete, 35% more steel was put in. But adhering to these rules became more time-consuming than originally thought and contributed to some major delays. As for the reactor itself, the main component, the pressure vessel, that was delivered in 2023 and installed in late 2024. The giant steel container, which will hold the nuclear fuel, was first lifted onto rails and inserted through an equipment hatch. Then, once inside the reactor building, it was gently rotated and lowered into place. Surrounding each of these vessels will be 4 steam generators, 25 meters long and weighing over 500 tons. After 6 years of design, manufacturing, and testing, the first one was delivered to the site in May 2024, following a journey from northern France across sea and road. Just next door to the reactor buildings are the absolutely massive turbine halls. 50 meters tall, these will house the largest turbines of their kind anywhere in the world. It doesn't look much like a finished power plant yet, but with so much activity on site, you'd be forgiven for assuming it must be close to the end. But you'd be wrong. It probably won't be operational until at least 2029, and that's just with one of the reactors running. Full power is now expected in 2031. This wasn't the original plan though, as the whole project was supposed to be finished by 2025 when contracts were first signed in 2016. Another concern has been the environmental impact, and it's not all to do with nuclear waste. Of course, that has been an issue for many people, and the plan is to ultimately store it hundreds of meters underground in a new type of specialized facility. Instead, a lot of the backlash is actually to do with fish. You see, nuclear plants require huge amounts of water to keep their reactors cool, and they have to get it from somewhere. To ensure enough water for Hinkley Point C, 8 kilometers of tunnels have been built connecting the site to the Bristol Channel. These will allow up to 120,000 liters of water to be transferred every second. The trouble is, the channel is full of fish, so there's a danger many will be pulled into the system by accident. Because of this, EDF is planning to introduce a fish recovery and return system. Then there was a requirement from the Marine Management Organization to install an acoustic deterrent. This would essentially blast sound underwater to scare fish away from the intakes. EDF isn't too keen on the idea though, calling it dangerous to install and unproven, which is why they've proposed an alternative, creating new salt marshes in the surrounding area. EDF says these will provide breeding grounds, food, and shelter for all kinds of wildlife. This, they claim, will make up for the fact it will be sucking literally tons of fish out of the water every month. But this decision has come under fire too, because hundreds of acres of land would have to be flooded to make these habitats. Some local farmers have objected to the idea alongside the local council. However, with a project like Hinkley Point C, it's all about perspective. Yes, what's happened so far hasn't been a roaring success, but building something this complex after so long was never going to be easy. Looking forward, there is even some cause for optimism. EDF believes the worst is behind them, and they have learned lessons from the setbacks they faced on the first reactor. Teams are using the lessons learned on Unit 1 to make the construction of Unit 220 to 30% more efficient. One example is they are now able to weld together the massive steel pools 4 times quicker than before. Their job is to house the reactor and shield against radiation. Another thing that makes this so important to get right is what's in the pipeline after the scheme is finally wrapped up. EDF is already making preparations for its next UK plant, Sizewell C in Suffolk. That will be a virtual replica of Hinkley Point C, and you can be pretty sure the company will want to avoid making similar mistakes again. With the UK planning to quadruple its nuclear capacity by the middle of this century, the country can't afford a repeat of this project's complications. And yet, when you really look at what's being built here, it truly is an astonishing feat of construction. As one of the birthplaces of atomic energy, the UK's lack of nuclear progress is somewhat surprising. But with Hinkley Point C, it's looking to regain some ground on an epic scale. After a difficult journey, it's the biggest energy decision the country has made in decades, but whether it will be seen as a good or a bad choice in years to come remains to be seen.